Good morning. I am Mr. Jojo Bandola, a student of Central Bicol State University of Agriculture, Sipocot. I am here to discuss to you a particular topic in computer organization, specifically in bus interconnection. So let's start in bus. Bus is a communication pathway connecting two or more devices. So it means bus serves as a connector that allows different devices to communicate with each other. Also, one of the characteristics of a bus is that it is a shared transmission medium. It is used to transfer or share control signals, data, or even addresses. A bus that connects major components like processor, memory, input-output devices, that is what we call the system bus. There are the three functional groups. First is data lines, second address lines, and the third is control lines. We will discuss it one by one. Data lines provide a path for moving data among system modules. So here in data lines, it is only being provided for data only. Address is not accommodated because data lines only accommodating data. Address lines are used to designate the source or destination of the data on the bus. So this line is only used for designating data, or it is used to address the location of the data in the components of a computer. Control lines are used to control the access to and use of the data and address lines. So this lines is used to control the access, because the data and address lines are shared by all components. There must be a means of controlling their use. Timing signals indicate the validity of data address information. Command signal specify operation to be performed. So timing signal, it is a responsible one for checking out if the data or address is valid. And the command signal, it is used to specify or to assign of what operation is valid to be performed. Now we are here in typical control lines. It includes first the memory write. So memory write, it is not literally meant of writing using a pencil or ball pen and paper. It is a control lines that is assigned. It is a control lines that is assigned to get the data from the bus and to move it to the designating location. Okay, the next one is memory read. It is the antonym or the reverse of memory write, which is it get the data in the access location and to move or place on the bus. So the function of memory write and memory read, it's only a reverse function. Next is input-output write. So input-output write designate the data to be moved or to send in input-output port. Input-output read, it get the data from the input-output port and to send it to the bus. We have here next the transfer acknowledge. So transfer acknowledge, it sign that the data is being accommodated to place on the bus. Next is bus grant. I mean bus request. So bus request, it send a request to gain control of the bus. That's only the function of bus request. Next is bus grant. Bus grant indicate the requesting module has been granted control. Next is interrupt acknowledge. Interrupt acknowledge that interrupt has been recognized or being accommodated. We may proceed to our last, which is clock. Clock, it is a timing. It is used to operation is sequential way of processing a data or step-by-step way of processing. We will now proceed to multiple bus hierarchies. Great number of devices are connected to the bus perform will suffer. The more devices attached to the bus, the greater the bus length and hence the greater the propagation delay. I will explain it to you. If the bus is attached to a great number of devices, it can affect the performance of the bus. Why? It is because of because bus is being attached to more devices, it needs a long length of the bus that will result to the delay of propagation. Because if the bus is long, it affects the accuracy of sending data or addresses in corresponding components. It will not be processed faster. What you see here right now is a traditional bus architecture. As you can see in this diagram, the bus that connect processor, local input output controller, cache, that is what we call the local bus. So what we see here, that cache is connected in the system bus, wherein main memory is also connected in, and the expansion bus interface. So it means it serves as the bridge of expansion bus and system bus to communicate with each other, and also to provide a connection to the lower components performance like network, SCSI, modem, and serial. Okay, that's all about traditional bus architecture. We may proceed here in high performance architecture. As what we see here, processor and cache bridge is also always connected in local bus. But what is the difference between cache in traditional bus architecture and here in high performance architecture? In traditional bus architecture, the cache is connected in system bus, but now here in high performance architecture, the bus is directly connected in high speed bus, which is supported the SSI, Firewire, Graphic, Video, and LAN. And high speed bus connected with expansion bus interface, which is also supported the low performance components, which is PAX, modem, and serial. That's all about high performance architecture. We have here the bus type, the dedicated bus and the multiplex bus. So what is the difference between dedicated and multiplex? Dedicated bus, it is only assigned for one function only, while multiplex, it is assigned for multiple purpose, or it is being designed for a multiple purpose. That's their difference. We see that the more advantage it gives in using a bus, I think we can see it in multiplex. Bus controller or arbiter is responsible for allocating time on the bus. We have the two types of timing, the synchronous timing and asynchronous timing. Next is bus width. The wider the data bus, the greater the number of bits transferred at one time. The wider the address bus, the greater the range of location that can be referenced. So it showed the advantage of bus width. Said that the wider the data bus, the greater the number. It is very common to us if the bus width is wider, it also can get a greater number of bits to be transferred. And the wider the address bus, the greater the range of location can be referenced. That's all. Thank you.